Welcome to Pradeep sir classes as PSC, and today we are in IIT Foundation course that is for class CSC, ICSE-10 as well as CBSC 10, but we are in ICSE-10 and the chapter number 2, that is work, energy, power. And students, and today's goal is the definition of work, what is the unit related with it, and what is the component of force and the component of displacement along the direction of force, or it may be along the direction of the displacement. You have to for the some processing of work you have to apply a force, and then what is positive, what is negative, and what is a zero work condition. Okay, so this is the goal of these classes. And students, I want to say you that if you are first in that particular class, then and you must see all the lectures and go back to the previous classes that I delivered one. So all the lectures are explain the moment of force and all about circular motion, all about the principle of moments and center of gravity, how to measure the center of gravity, and most interesting lectures. Okay, so let's today's start with work, and then energy, and then power. Okay, so let's start with work, students. First of all, I want to tell you that sometimes you are writing something or drinking water, or it may be within your room and your mom just suddenly come to you and said, what are you doing better? Then you can say that mom, some work is to be done. Then what is the difference between the work, the mental or physical work done with the scientific process? What is work done in scientific process? Students, and if we suppose push the fridge and the displacement takes place along the direction of this one, and I push this one and move a particular distance, but if I try to move that particular one, there is the, if we push the wall and doesn't and fail to move it, then we can say that the work is zero. But in physically or mentally, when you are read some books, some pages of the books, and the mental pressure is created, then you can say that the work is done. But in physics, you are nothing, you are not doing that possible work. Okay, so work is done, you can say that work is done when you push that particular body and moves that one along the direction of force. Okay, so when we push the fridge and it moves along the direction of force, then we can say that we are doing some work. When we push the wall and it doesn't move, then we can't say that I do something work. If you if you lift that water bottle in a specific height, then you can say that you do some work. And as well as the gravity acts downward, that is the gravity do some work. Okay, so what is about, first of all students, what is about work done, how can we measure the work, or when the work is said to be positive, negative, or zero work. So when you push the wall and the wall doesn't move, you cannot move that particular wall, then you can say that the displacement is zero and the work done is zero work. When you lift that particular bottle with your muscle power, with your hands, then you can say that this is positive work. And if as well as the gravity doing something work, because the gravity act downward, but this is the displacement is along this direction, so this is 180 degree, and you can say that this is negative work. So first of all students, start with the definition of work. So take your copy and pen and make a note, a small note with some concepts, with some numerical process, and if possible then the different units, with the help of different unit and the formula we can do some numericals also. Okay, first of all, students, what is work? What is work? What is work? Or you can, what is work in physics? In physics, what is work in physics? Or you can write as define work done. Define work done. Work done. So what is the definition of work done? Suppose students, this is an object. This is an object, and this is the point of application of force. This is the point of application of force. This is the point of application of force. Okay, what is point of application of force? What is point of application of force? Where you can exert an appreciable force. Appreciable means you have to move that particular one. You have to move that particular object along the direction of force. Along the direction of force. So this is the earth surfaces, and you push that object and it moves up to a particular distance. Up to a particular distance, and if this is the application of force, then this point moves at this position. So this is the displacement, and the displacement takes place along the application of force. So it is a vector quantity as well as it is also a vector quantity. So displacement takes place along the direction of force. So what is the definition of work? Work is said to be done. Work is said to be done. Work is said to be done when the body displaces some distance, along the direction of force applied. Work is said to be done when the body displaces some distance, when the body moves some distances along the direction of force applied. So force is applied along this direction and the body moves at that position with some displacement. So we can say that the work is done. So this is the definition of work done. Work is said to be done when the body displaces some distances along the direction of force applied. Or the body move along the direction of force. We can say that simply along the direction. If we move a particular body, then we can say that the work is said to be done. Okay. So students, in physics or science, or in mathematics, you can say that the work when the work is done, when it displaces the body. So this is the main difference. When you writing something, then you can't do some work. It is not a work process. In physics, you have to move that particular. So work done. What is the magnitude of work? What is the magnitude? Next question is question number 2. What is the measurement? Magnitude of this. Magnitude of work. What is the magnitude of work? So work equal to. So work is the product of. So work is the product of force applied force applied, or applied force we can write as applied force into displacement So work done equal to force into displacement. This is just multiplication. So work done equal to force into displacement. This is what is the magnitude of force. So this is work done equal to force into displacement. Students, think this is an object and you moves that object at this one with a force of F equal to suppose 30 Newton, and you can move this one object. There is the point of application of this one, and the distance is 20 meter, and the distance is 20 meter. Then the work is 30 into 20, that is Joule is the unit. So this is 600 Joule. But if you applied 20 Newton force, that is F dash equal to 20 Newton, and move 20 meter, then the work done for the second case is 20 into 20, that is 400 Joule. So when that is F is greater than F dash, F is greater than F dash. Similarly, the work done in the first process is also greater than for the second one. That is 600, and the difference is 200 Joule. So when the applied force is greater, then you can say that the work is also greater, and if the displacement is greater, then you can show that, or you can say that the work is also a greater value. So work depends upon mainly the applied force as well as the displacement of the body along the direction of force. Now students, we are going to know what is the actual expression for the work done. Okay, what is the actual expression for the work done? So measurement of work, and take a heading, measurement of work. So students, this is an object and kept on the inclined plane, okay, with an inclination of theta. So an object is kept within on an inclined plane with inclination theta, and a force is act along this direction. But the body displaces along this direction. So this is the application. You can say that this is the application of force, or this is the application point, and this is, so the displacement is from here to there. This it is, suppose S. It is the distance S. Okay. So students, work done equal to force into displacement, but you have to take a component. What is component? That is the projection of the displacement on that particular one. What is projection? Suppose students, you can see that here a shadow is shown here of this hand. Yes or no? And I think you are able to see the shadow of this one. So if this is the inclined plane and you can take a projection on that particular surfaces, that is, you have to lighten here and take a shadow of this displacement here, shadow of this displacement here. So you can see that that particular portion can make a shadow of this inclination. This is so this particular displacement can show its shadow for that particular one. So what is the value of this one? If this is the hypotenuse and this is theta, so this is the acute angle, so this is perpendicular and this is base and this is hypotenuse. So what is the value of base? You can easily say that this is O, A and B. This O and since OAB, a right angle triangle. So right angle triangle OAB, then cos theta equal to base by hypotenuse. So base, it is a base one. So base equal to base by hypotenuse, that is S. So B equal to S cos theta. So B equal to S cos theta. So this one is S cos theta. So this is the projection of the displacement on the ground. That is the projection of the inclination of the ground. So this is S cos theta. So work done equal to force into S cos theta. Because you have to take the force along the displacement, force and the displacement along a particular direction, and it is the definition. But the definition says that work is said to be done when you apply the force on that body and it moves through along the direction of force. So you have to take the force, the direction of the force is along this direction and the displacement takes place along this direction. So you have to take a component of displacement along this direction. So this is called component. This is called component of displacement. Component of displacement. Component of displacement. So the component of displacement along the force. Component of displacement, that is S cos theta, along the force is S cos theta. So work done equal to Fs cos theta. So this is the actual expression for work done. Fs cos theta. And student, this is case 1. Suppose case 1. And if you want to the component of force along the direction of displacement, so you can take as this is case 2. So this is the ground level and this is the inclination, and the object you want to move displaces, and this is the application of force along this direction, and the body move. This is the displacement. So the displacement is S1 from this one. This is the point of application S. So you have to take the force 1. Force is acted along this direction. So component of force. So force act along this direction. Along this direction, force is act along this direction. So the component of the force along this direction is F cos theta. What is this? F cos theta. So here it is the direction of force. So the force along this direction is F cos theta. So here also the work done is W equal to F cos theta into S. So component of force, and you can write as component of force. You can write as component of force along displacement. Along displacement or inclination. So students, you can write component of force along displacement or along inclination. Along inclination is F cos theta. So the work done is F cos theta into S, and this is again Fs cos theta. Fs cos theta. So work done equal to Fs cos theta again. So this is the measurement of work. Fs cos theta. In physics, students, there is a branch of physics where deals with the specific physical quantity, that is the vector as well as the scalar. What is the scalar? Students, you know that what are the scalar? That possesses only magnitude. Suppose your mom says that a beta goes along these directions with 2 kilometers and go to a specific market. Specific market. Here there is a specific market. So your mom says that goes along this direction with that particular specific market. So you have to go that along this direction. So this is a vector quantity. Suppose your teacher says 3 steps, take 3 steps along east. So east is the direction and your 3 step is the magnitude of this displacement. Okay, so 3 steps is the magnitude, and along the east or due east or due west or north or it may be south, it is a direction. So this is a vector quantity like displacement. So displacement is a vector quantity. And force, you have to apply a force along a specific direction. Gravity always act along a specific direction, so force is a vector quantity. So what is magnitude? If there is a magnitude, and if you move within your room, suppose if you take your digital watch and you count your steps and you move here and there, and the step shows that 2000 steps, then you can calculate it as, or it may be something 20 meter or 500 meter, it may be. So this one is the distance, and you can move anywhere within the room. But if this is displacement, then you have to take a specific direction. That is, if A and B are the 2 positions and you move along this direction or along this direction, but if you move along that particular direction, then you can say that this is the displacement and this all are the distance, only distance, since the direction is always changing at all point. So what is distance? What is displacement? There is some physical quantity are there that are not related with direction, then we can say that, but take into account the magnitude only, that is called scalars. And when scalar plus direction, then we can say that this is vector. Okay, so force is a vector quantity, but work is a scalar quantity. So at that particular chapter, there are 3 quantity, that is work done, the force and the displacement. So work is scalar and the force is the vector and the displacement, it is a vector quantity. And when we take product of this one, when you take a product of this one, so if we explain the equation, there is work equal to force Fs cos theta, then this is scalar, this is a scalar 1, and this is a vector. A displacement is also a vector. So when you take the product of 2 vector, then you can write as F dot S. What is, and this is called dot product. Dot product. What is dot product? What is dot product, students? Don't go for that particular one, because scalar, for that particular concepts I discuss a new chapter, that is vector, and then you can see that particular one, the basic concepts related with. But this chapter is mainly starts with a concepts of 11th concepts. So don't go for that particular detail. Suppose you can say that I can say that the work done equal to suppose it is written as this one, then it is wrong. This is called cross product. Cross product. This is wrong method, and you can write this is F into S, then it is simple multiplication. So it is right. This is a wrong, because when two physical quantity are multiplied and if the quantity is a vector, then we cannot take as cross product, since this equation leads to a scalar quantity. So a scalar equal to two vector, that is you have to take a dot product. So scalar, this is a scalar equal to vector dot vector, but if this is vector, then you can write as vector cross vector. So this is cross product and this is dot product, and if you write like this one, so you can take it account this is simple multiplication, and you cannot write a arrow over it. Okay, then it's mean that this is the multiplication of two vector. When multiplication two vector occur, then the result will be a vector quantity, but here the work done is a scalar. So don't go for that too much details. Just know that work is a scalar quantity, force is a vector quantity, displacement is also a vector quantity, and you have to take work done equal to F dot S, and the equation is W equal to F s cos theta. Okay, W equal to F s cos theta. Let's students discuss with positive work. What is positive work? When, so work done equal to Fs cos theta. When theta equal to theta is greater than 0, is when theta are less than 90 degree. Okay, when theta less than 90 degree, and then you can say that students cos 0 degree, this is leads to a 1 value, and cos 90 degree, this is equal to 0, and cos 180 degree, and this is equal to minus 1. You know that particular value. Cos 180 means minus 1. Okay. So cos 0 degree means 1, cos 90 means 0, and cos 180 equal to minus 1. So work done equal to Fs cos theta, and when theta less than 90 degree, then you can say that the work is positive. This is an object, and you want to push that one along the direction of force. So this is the application of force, and the body moves from a specific distance S, so it is a vector quantity. So work done equal to F dot S or Fs cos 0 degree, since force act along this direction and the displacement also takes place along the direction, so you can say that, and this is Fs cos 1, so Fs. So this is the value of maximum work done. This is the condition of maximum work done. Max work. We can write as max work. Okay. So this is positive work done. So if I push that particular fridge and displaces along the direction of force applied, then you can say that this is positive. If I lift the bottle, so the bottle moves along this direction and the application of force is along this direction, so the force applied along the direction of displacement, so the work done is positive. But when we lift the bottle, negative work. When you lift the bottle and the force, the weight act along this direction, there is mg. Mg is the force, and I displaces the bottle along this direction. So the displacement is along this direction, but the force is along this direction. The force is along this direction and the displacement along this direction. So the angle is 180 degree. So the angle is 180 degree, and you can see that the work is equal to Fs cos 180 degree, and students, you have to memorize the value of cos 180 degree, that is -1. So this is -1. So the gravity doing some work, that is negative work. So when you lift the bottle, then you can do a positive work, but the gravity, work done by the gravity is negative, since the force act along the direction, along the downward direction, and the displacement takes place along the opposite direction. So this is the case of negative work. And students, if you tie the stone and move on a circular path, then the displacement always takes place along this direction and the force along this direction. So force and displacement make an angle of so this is 90 degree. You can see here this is 90 degree. So the work done is, so the work done for that particular is work equal to Fs cos 90 degree, and the value of cos 90 degree is 0. So Fs equal 0, this is equal to 0. So this is called, students, zero work. So this is called zero work. What is zero work? When the force and the displacement takes place within a 90 degree, then you can say that the work is zero. Okay. So students, think about a suitcase. You move with the suitcase. So this is the box, and it acts in this direction mg, and you displaces this one along this direction s. So this is always 90 degree. So the gravitational work done for that particular one is 0, since the gravity acts along this direction and the displacement takes place along this direction. When the angle is 90 degree, then you can say that the work is 0. And students, let's discuss with some cases of work done when it is a zero work, otherwise it is a negative work or positive work. So you applied a force along this direction, and you move that particular one with some distances, yes, this is the S. And at the meantime, there is a frictional force, and this is the applied force along this direction, and the frictional force act, this is frictional force, this is displacement takes place along this direction. So the work done by you, work done equal to Fs cos 0 degree, and the work done by the frictional force, that is Fs cos 180 degree. So this work done is, students, Fs. So this is positive work, and this is minus of this. So this is negative work. So when you applied a force and move the body along the direction of force, then you do some work that is called positive, and as well as the frictional force doing some work, and that is negative work. Okay, so what is positive and what is negative, I think it is clear for you. And suppose a coolie holding his weight on his head and standing on the platform. A coolie holding the weight and standing on the platform. What is the work done in this process? If it is holding and standing at that particular position, then we can say that the displacement is 0. The displacement is 0, and the work done is here again 0. So the displacement work done equal to Fs cos theta, and here the displacement is 0. So this is also 0. so the work done is 0. When the displacement is 0, then the work done is 0. When the angle is 90 degree, then the work done is 0. And when the angle is less than 90 degree, then you can say that the work done is positive. And when the angle is greater than 90 degree, that is obtuse, then we can say that the work done is negative. So when theta less than 90 degree, then this is a positive work done, and when it is greater than 90 degree, then this is negative work done. Here this is 180, so 180 is greater than 90. So these all are the cases of work done when the work is positive, when the work is negative, and when the work is a zero work. And next topic is students, and the next one is we can discuss some numericals obviously, but the first of all you have to know the different unit and their definitions, related definition. So the unit of work, and most of all students, most probably the unit is used in Cgs system and MK system, and this is called absolute unit, and the gravitational format, gravitational unit, as well as the gravitational unit. So first of all students, I discuss with absolute unit and then gravitational unit. What is about absolute unit? You know that CGS means that centimeter, gram, second, centimeter and gram, second system, and this is MKS system, so this is meter, kilogram, second. So in CGS system, there is work done equal to Fs cos theta. So F equal to, in SI system or CGS system you can write as, so work equal to, in CGS system this is force into displacement, so force equal to, you know that this is dyne and S is for the displacement, so it is a centimeter, so it is centimeter. So dyne centimeter is the unit of work, and you can write as simple as arc, ERG. Okay, so this is CGS system, and for the SI system it is work done equal to force into displacement, so force is in Newton and this is in meter, so you can simply write as Joule. So Joule is the unit of work done in MKS system. And students, for gravitational unit, in place of force you can write as gram force. You can write as gram force and then centimeter. So gram force centimeter is the gravitational unit, and here you can write as kg force into centimeter. Kg force into, sorry, this is meter, so kg force into meter. So this is the gravitational unit, and this is also the gravitational unit in CGS system. So this is the absolute unit, and this is gravitational unit, and this is absolute unit, and this is also gravitational unit for the respective system. That is, in CGS system you can write as gram force into centimeter, or dyne centimeter, or simply you can write as arc. Okay, so these are the different unit system, and then we relate the different unit system. We can relate the different unit system, and we can also define that particular one. So first of all, what is the definition of Joule? What is the definition of Joule? Or simple, you can write as symbolically J. So what is the definition of J? 1 joule work is said to be done. 1 joule of work is 1 joule work is said to be done when 1 Newton force can displaces a body through 1 meter along the direction of force, along the direction of force. So 1 joule work is said to be done when 1 Newton force can displaces a body through 1 meter. So this is, suppose a body, and you can apply it a force of 1 Newton and you displaces the body through 1 meter. So this is the, if you take as this is the application of force, this is the point of application, then you have to take here. So this is 1 meter. And if you take the center of gravity of this one, then you can take as this is the center of gravity. So this is 1 meter and this is 1 Newton. Then you multiply this and this one and get 1 joule. So 1 joule equal to, 1 joule equal to 1 Newton into 1 meter. So 1 joule equal to 1 Newton into 1 meter, and you can say that 1 joule work is said to be done when 1 Newton force can displaces the body through 1 meter along the displacement, along the force applied. So this is the direction of the force and this is also the displacement S, and this is force. So when force and displacement act along a specific direction and you can make a multiplication of this and this one, then you easily get a 1 joule of work, that is the multiplication of 1 Newton and 1 meter. And then 1 arc. So students, just substitute the value. This is joule. In place of joule you can write 1 arc. So 1 arc work is said to be done when 1 dyne force can displace a body through 1 centimeter along the direction of force. So this is 1 dyne, this is 1 centimeter, and this is 1 arc, and this is 1 arc equal to 1 dyne into 1 centimeter. So 1 arc equal to 1 dyne into 1 centimeter. So this is the definition of work, unit of work. Okay, so unit of work, and you can also relate the relationship. You can also calculate or show a relationship between the SI and the Cgs system of work done. So 1 joule equal to 1 Newton into 1 meter, and 1 Newton, students, this is 10 to the power of 5 dyne, this is 10 to the power of 5 dyne, and 1 meter means 100 centimeter, so 5 and then 2, so this is 10 to the power of 7 dyne centimeters. What is about dyne centimeters, students? This is arc, so this is 10 to the power of 7 arc. So 1 joule equal to 10 to the power of 7 arc. Students, last of all, I want to say, if this channel, you like this channel and you think that wow, the concepts and all the concepts are explained with some different way, then must subscribe this channel and share with your friends. And last of all, I want to say, continue your study and wait for the next excitations. Okay, thank you.